All right, so in this video, we're going to discuss solving an equation by completing the square, right? So you should be familiar with this form of the equation, right? ax squared plus bx plus c, and then equal to some number that I just made, d. What we're going to do is convert this equation into what's called perfect squared form. Perfect squared form would be, in these parentheses, you have x plus or minus some number, right? All to the power of 2, all squared. And that's equal to some number. And we're going to go into how to convert that. That's the main method of completing the square. What's important to note is that you always want this a term, the thing in front of the x squared, to be a 1, right? If you see in this first example we're going to go through in a little bit, you don't see a number up here. That means there's a 1 technically there. We'll discuss ways to complete the square when the number here is something other than just 1. There are methods of completing the square that account for that, and we'll go into those examples in a little bit. So one thing that's important to, talk about is when should you use completing the square? Because here's the thing, it's not typically the best method. I find it rarely actually better than factoring. Factoring is always going to be better. And I think it's just about as, in terms of difficulty level of using it, it's equal to just using the quadratic equation, which works in every scenario. So why should you know completing the square? There are other topics that require it that are not solving equations. A lot of algebra classes might do this towards the end, where you have to deal with equations of a circle, which this is necessary when figuring out certain parts of that. And I know they definitely use this in geometry classes when doing equations for circles. So this video is both for algebra students and geometry students, I guess. Okay, now I'm going to show you the method for completing the square, and I think that's best done through examples. So we're just going to go straight into this one. So first things first, let's get this into perfect squared form. How do we do that? Step 1, get your x's alone, right? And everything else, bring it to the other side. So see this, how this positive 11 doesn't have an x with it? I need to bring it over, okay? So that's what we'll do. X squared minus 12x, and then I subtract 11 to both sides, so I get minus 11 here. The next step, step 2, would be I need to add a number to both sides, a specific number. How do I find out what that number is? It's an easy method, okay? You see this term here, what would normally be your b term? What we're going to do is we're going to take that number, negative 12. We're going to cut it in half. So first, divide by 2. And that's going to get us negative 6. Okay? Next, we're going to square it. So negative 6 squared gets us a positive 36. Now that is the number we add to both sides. So this becomes x squared minus 12x plus 36, and that's equal to, and then we have to add positive 36 and negative 11, and what that should be is positive 25. Okay, so that's step 2. Step 3 is to factor this side, okay, using a method that you might already be familiar with, AM method. It's something that you're kind of required to know before you do completing the square. Now, I have a video on that, so if you're fuzzy on AM method for factoring, go watch that video. So what we're going to do is we need to find a number that adds to this and multiplies to this, okay? So it's going to be x, and it looks like negative 6 and negative 6 are the two numbers, right? Negative 6 plus negative 6 add to negative 12. Negative 6 and negative 6 multiply to positive 36. And that's equal to 25. Okay? Now, we can square this, we can combine it. right? Since they're both the same thing, we can now just change this to x minus 6 squared is equal to 25. Now we have it in perfect squared form. One thing I want to note, and it's going to be like a shortcut method, is this number here, right, and what eventually ends up being this number here, it always ends up being this middle term from step 2, right? We cut the negative 12 in half and squared it. This term always ends up being your middle term that's cut in half. Okay, so that's a good shortcut method to essentially skipping right to this step. All right, so now that we have it in perfect squared form, what do we do? So I'm just going to write to the side here because I ran out of room. X minus 6 squared equals 25. So now we solve. We square root both sides. So now we have x minus 6. And then when you take the square root of 25, you have to account for the fact that negative 5 squared and positive 5 squared both turn into positive 25. So we need a plus minus 5 here. Okay? And now we get x alone. So x equals plus or minus 5. And then we add 6 to both sides to get plus or minus 5 plus 6. Now, what does this mean, the plus or minus 5? It means we need to do one version of the equation where we use a positive 5, and one version of the equation where we use a negative 5. So let's split that up. So what's positive 5 plus 6? Well, that just becomes x equals 11. And what is negative 5 plus 6? Well, that becomes x equals positive 1, right? So we end up with two answers, x equals 11 and x equals positive 1. So positive 11 and positive 1. So here are the steps to remember. First, bring your x's to one side, bring everything else to the other side. Step 2, figure out the special number to add to both sides, that magic number. The way you do it, take that term with just the x, what was originally that middle term, cut it in half, square it. That's the special number. Okay? And now that you have 36 added to both sides, you can essentially skip straight to this and make it x with whatever this number is. So it's a negative 6 in this case, so I made it x minus 6 squared equal to 25. And then I solved algebraically the way you normally would. Okay, so now let's go through some more examples. All right, so this first example is we have x squared plus 14x minus 51 equals 0. I suggest pausing the video and trying this out yourself, remembering the steps we just went through. Also, I will write the steps for completing the square that I talked about in the description. So take a look at that and copy them down yourself, just, for notes to reference. Okay, so how do we solve this? Well, step 1, get our x's to one side, get everything else on the other, right? So that's step 1, and we need to bring this negative 51 over to this side. We add 51, and we get x squared plus 14x equals 51. Now we want to find the magic number, step 2, to add to both sides. So what do we do? To find that number, we take that middle term, which in this case is positive 14. We first divide it by 2. 14 divided by 2 equals 7. And next, we square it. 7 squared is 49. Okay? So 49 is what we're adding to both sides. So this becomes x squared plus 14 plus 49 equals, and then 51 plus 49 is 100. Okay? So now we need to figure out how to get it into perfect squared form. So like I said, you can normally skip that middle part that I went to and go right to this. I'm going to leave a little room because I'm going to write the middle part in after. Okay? So I can skip straight to being x, then whatever this number was, that middle term cut in half, which was a positive 7 squared. And that's equal to 100. Now, what was that middle step? Right, because I still think it's important to kind of talk about for now, while we're still learning completing the square. And that was factoring this by AM method. I need to find two numbers that add to 14 and multiply to 49. They happen to both be positive 7, right? 7 plus 7 equals 14. 7 times 7 equals 49. So that's going to be x plus 7 multiplied by x plus 7, and that's equal to 100. And then I was able to combine these to become an x plus 7 squared. All right? So what is the next step? Right? So that was step 2. Getting it to perfect square form was step 3. And now we've done completing the square. Now it's time to actually solve. I take the square root of both sides, here and here. This becomes x plus 7 is equal to plus or minus. Square root of 10 is 100. Or it could also be, square root of 100 is 10. Or it could also be negative 10. So we do a plus or minus 10 there. Now to get x alone, we subtract 7 to both sides. So subtract by 7, we get x is equal to plus or minus 10 minus 7. Now what do we do with the plus or minus? We have to remember we have two different scenarios. It could be positive 10 or negative 10. So let's look at both. So positive 10 minus 7, right? X equals positive 10 minus 7. And that gets us x is equal to positive 3. Our other option is x equals negative 10 minus 7. And the way you subtract negatives, you keep change. It's something you should be familiar with, right? I change this to a positive, change this to a negative, and I get x equals negative 17. And both of these would be my final answer. All right, so let's look at one more example in kind of this, this form where this number up front is 1. And then I'll do another 2 examples where they're slightly different. All right, so this next example seems a little more complicated, but it's probably not as hard as it looks. So go ahead, pause the video, try it out. All right, so we have to go through our steps. Step 1, anything that's not an x, bring it to the other side. Everything that has an x stays on this side. So we have to bring the negative 91 over to this side. Right, so we add 91 to both sides. This cancels. This becomes now x squared minus 4x equals 7 plus 91, which is 98. Step 2, find the special number, find the magic number. Okay, so that's going to be negative 4 divided by 2, which is negative 2. And that is going to now be negative 2 squared, which is positive 4. So positive 4 is what I bring to both sides. So x squared minus 4x plus 4 is equal to, what is 98 plus 4? 102. Now I can go straight to, and I'll still leave a little bit of room, I'll go straight to this part where I now just do x, and then whatever that middle term was, which was a negative 2, x minus 2 squared is equal to 102. That middle step, if you're still having trouble with this part of just skipping to the getting it in perfect squared form, you could just factor this AM method. What adds to negative 4 and multiplies to positive 4? Negative 2 and negative 2. and that equals 102. And then from there, you can combine them to become x minus 2 squared. Okay, so now we have it in perfect squared form, right? All our steps are complete. We have to solve. So we square root both sides to get rid of the exponent. And we get x minus 2 equals square root of 102, plus or minus. Now, 102 isn't a perfect square, okay? So we can leave it as a square root. You should be familiar with working with radicals from a previous unit. Now, what we do, we add the negative 2 to both sides, or we add 2 to both sides to get rid of this negative 2, and we get x is equal to plus or minus rad 102 plus 2. And typically, if you can't reduce that, you could leave that as your final answer. Or you might be required to separate them, right? X can equal positive rad 102 plus 2, or x equals negative rad 102 plus 2. And both of these would be your final answer. So it depends on what your teacher is asking or what the exam is asking for. But that's pretty much it. Let's move on to the next example. All right, so we're going to start off light with this next example. So what we have is negative x squared plus 18x plus 40 equals 0. Now, here up front, we have a negative sign, something we haven't had before. And something I mentioned, we're technically not allowed, I guess. There's something you can't really complete the square with while it's there. You want that number up here to be a positive 1. So how do you get rid of it when it's just a negative sign? This is a technique useful in multiple areas, not just completing the square. You could just multiply negative 1 to everything. Okay, so let's look at that. If I take this and multiply negative 1 to both sides, so negative 1 here, and I'm going to write a negative 1 here even though there's a 0 here. It's just to reinforce whatever you do to one side, you do to the other. Okay, so negative 1 times negative x squared should just be positive x squared. Negative 18x times negative 1 is minus 18x. And negative 40 times negative 1 is negative 40, or positive 40 times negative 1 is negative 40. And 0 times negative 1 should still just be 0. All right, so from here, we can see that we have our normal scenario. We're back to the original version of the equation. We can just do our steps the way we normally would. So, step 1, bring everything over that's not an x. Okay, so I bring the 40, add it to both sides, just like that. And now I'm left with x squared minus 18x equals positive 40. Now I need to find that special number. Okay, we're going to take this negative 18 minus 18. We're going to cut it in half. And we're going to get negative 9. And then we take that negative 9, we square it. And that gets us 81. Okay? Now 81 is what we add to both sides. And we can do x squared minus 18 x plus 81, and then 40 plus 81 should be 121. 121. Okay, so from here, we do our factoring thing. We can bring it straight to the perfect squared form, right? And I'm going to skip that middle step because at this point, I think you guys know what I'm talking about when I'm skipping. So it's going to be x with whatever that middle number was from step 2, that, middle point, which was minus 9, and that's squared, is equal to 121. So our completing the square steps are done, and now we have to do the actual algebra of solving. So square root both sides, we get x minus 9 is equal to square root of 121 is 11, plus or minus. And then from here we can bring the, sorry about that, we can bring the 9 over, plus 9, that cancels, and we get x equals plus or minus 11 plus 9. Now, this is something we can obviously simplify, so we break it up into our two scenarios, right? We have x equals a positive 11 plus 9, and x equals negative 11 plus 9. So what are our two answers? Well, x can equal 20, and x can equal negative 2. Now let's just go through one more example. All right, so here's the last problem we're going through. We have 8x squared plus 16x minus 42 equals 0. So what do? We want to get rid of that 8 up front. How do you typically cancel out numbers, right? We want to cancel out the 8. Well, you just do the opposite operation. So if you divide 8 to every term, then you should finally have an equation where your leading coefficient, by that I mean the number in front of the x squared, that number is just 1. So here's what we'll do. Divide both sides by 8. Like I said, I know dividing any 0 with anything, that just gets you 0, but I'm just emphasizing whatever you do to one side, you do to the other. Okay? So 8x squared divided by 8 is just x squared plus 16x divided by 8, 2x, minus 42 divided by 8 is 42 over 8, which simplifies to 21 over 4. Okay? And that is equal to 0. Now, from here, we bring everything that's not an x. We begin with our steps again. Anything that's not an x, we bring it over to one side. Anything that is an x, we bring it over to the other, right? Sometimes, you might have some x terms on opposite sides of the equation. All you have to do is just subtract and bring those together, okay? So we add 21 over 4 to both sides, and we're left with x plus 2x is equal to 21 over 4. What's step 2? Well, step 2, we got to find the special number, right? So we take our 2 right here. It was our original b term. And we take 2, we cut it in half. So 2 over 2, and that gets us 1. And then we do 1 squared, which is 1. So 1 is what we add to both sides. Okay? So what I'm going to do here, that should be a squared. What I'm going to do is I'm going to assume that you know how to add fractions. If you're up to this topic, you should be in 8th grade most likely, maybe 9th, right? You really should know how to add fractions at this point. If you have trouble with that, legitimately just do a bunch of practice on that. There are plenty of resources available online, right? So 2x and then plus 1 here, and then 21 over 4 plus 1 should get you 25 over 4. Right? What I did is this is technically plus 1 here and plus 1 here. Then I converted the 1 into a 4 over 4 and added. All right? So next, I bring this into perfect squared form. All right? Which is just going to be x plus 1, right, that number from up there, squared. And that's equal to 25 over 4. And like I've been saying, we're now done with the completing the square portion. Now, time to do the algebra, right? Just, isolate x, that whole thing. Get x alone. So, square rooting both sides, like this, will get us x plus 1 is equal to square root of 25 over 4. Now, we can split this up, and I'm going to continue writing this all the way here, just because I ran out of room, right? X plus 1 equals square root 25 over 4, yeah? What we can do is split this up to an x plus 1 equals square root of 25 over square root of 4. That's something you're able to do when you're taking the square root of an entire fraction. So, x plus 1 should equal plus or minus, what's the square root of 25? It's 5. 5. And what's the square root of 4? It's 2. Simple as that, right? Now we bring the we bring the 1 over to the other side, and we get x equals plus or minus 5 over 2 minus 1. And then we do the thing where we split it up, right? We do x equals a positive 5 over 2 minus 1, which gets us an x equals 3 over 2. That's one of our answers. And then we also have x equals negative 5 over 2 minus 1, which gets us x equals negative 7 over 2. So that should cover a bunch of different versions of completing the square. All right. What's important to know is make sure whenever you're given an equation, you have to do completing the square, and solve by completing the square. That a term up front, your leading coefficient, is what it's called, is 1. If not, you can make it 1 by dividing that number to every term, dividing that number on both sides. Or if it's just a negative 1, you just multiply negative 1 to both sides. Once you get it into the proper form, where that a term is 1, step 1, bring all your x's to one side, all your constant terms to the other. Step 2 is to find the special number, right? And it's going to be that b term divided by 2 squared. Step 3 is to then convert it to perfect squared form. And then after that, you solve. If there are any questions, throw it down in the comments, but other than that, you guys are now experts. Good luck.